So, welcome to Consumer Theory Part 4. Before this lecture, there are three more parts about consumer theory, in which we have covered curved regulars, perfect substitutes, perfect complements, max function, and some many interesting and intuitive concepts about consumer theory. So, if you haven't covered those videos, do cover those parts as well. Today, we will take our discussion further and discuss Quasilinear utility and concave utility function. So, let's begin. Now, first of all, before going into the main core technicalities about Quasilinear utility, let me revise the very first concept we did in part 1 for consumer theory. That was, if there is an income change, let's suppose income increase, they can happen three decisions by a consumer about, let us suppose, good X. It can increase, it can stay constant, it can fall. In this case, we say it to be a normal good. In this case, we say it to be a non-linear good, non-linear good. And in this case, we say it to be a inferior good, to be an inferior. Now, another thing we can add to this analysis is that in this case, there can be three bifurcations for income elasticity of demand. For income elasticity, we say dq by dm into m by q. Change in quantity demanded upon change in income into income upon quantity. Okay, so here it can be that our income elasticity is between 0 to 1, that is relatively inelastic demand. This indicates necessity goods. It can be that our income elasticity is equal to 1. We say them to be linear good, same proportion. The proportion by which income increases, demand for X increases in the same proportion. We say it to be linear good. In case it is greater than 1, we say them to be luxury goods. This you must have also done in semester 1 introductory micro course. But anyways, for non-linear goods, now this is the interesting one. For non-linear good, we have income elasticity equal to 0. Like, no matter how much income increases, you will not increase your consumption of good X. Moving to inferior good. Now for inferior good, we have the case EM is less than 0. But we won't be talking about this case much. We'll be restricting ourselves to the discussion on non-linear good and linear good. Okay, so let's move further and try to understand what really Quasilinear utility function tells us or is trying to explain us. Okay, so let us suppose you use salt in food. Okay, for example, this is an example often taught everywhere for Quasilinear utility. Now you use 2 packets of salt every month, per month, let us suppose. Okay, now after your hard work and your job performance, suppose your income increases. Now, will you actually increase your salt consumption? Like, you eat the same quantity of food every day. Like, it may vary from some days to the other days, but you will not generally, increase your salt consumption drastically. Like, you would keep it approximately equal to 2 packets only. Okay, there is no impact on uh, the consumption of your salt in food by a increase in income. There's just a marginal impact, if you can also say it in another point of view, but not a major impact. So here we can assume the expenditure on packets of salt or the good salt as kind of a non-linear good. A non-linear good. Okay. So this was just kind of an idea to get the feel of Quasilinear utility. Now let's move to a more formal definition or more formal points about it. Now we are assuming in our analysis that X is a nonlinear good. X is a nonlinear good. Now there are 2 points which are very very important. Like the income of the consumer uh, will always be equal, greater than or equal to the expenditure on non-linear commodity. That is X star, the equilibrium value into P1. Okay, and the other point is the consumer gives priority to non-linear good and then moves to the other good. Okay, priority to non-linear commodity. Okay, so enough discussion on the rough sides of it. Now let us write a general form for the non-linear commodity. Now what we understand by quasi-linear is that it is part linear, part non-linear. So what we mean to say by this is that u of xy equals v of x plus y. Now the moment you see v of x, like a term like v of x, you should understand that this is a non-linear commodity and this is a linear commodity. Okay. Now the Vx, it is not fixed. The functional transformation of Vx is not fixed. It can be root x plus y. It can be log x plus y. It can be any functional form. It can be e to the power x plus y. Okay. So these are many many transformations. There's no end to it. So got to understand that wherever the term Vx plus y comes, or in another sense, if we can also reverse it, you can also have in any question that x plus v of y. The analysis remains the same. Reverse is also true. Okay. Now let's restrict ourselves to the vx plus y case only for simplicity purposes. Okay. Let's see how are the ICs made in this utility function. Okay. So you can refer to Varian or Nicholson and Snyder, whichever book you are using for your reference. So in this nearest star point about quasi-linear utility is that ICs are vertical translates of each other. Okay, this line you can also find in Varian in the paragraph about Quasilinear utility and that figure. Okay, now what we mean by vertical translates is that let us draw normal IC kind of a, we have two good space x and y, we have x here, y here. Now this is one IC, this another IC. Okay, and let us suppose that after using the MRS equals px upon py condition, now since these are convex ICs, we are using the tangency condition. We have got x star to be this. X is our non-linear good, and write in short here, and y is our linear commodity. Now as income is increasing, we will be moving on to higher and higher IC. But you can notice that we are not changing a consumption of X, good X, which is non-linear good, until the income reaches some fixed range. We are increasing X, but after uh, there is some stable expenditure on X, the non-linear commodity. Beyond that, any increase in income is not inducing any change in the consumption of Y, in the consumption of X. Okay, so what we mean to say by vertical translates is that in reference to the non-linear commodity, the ICs would be symmetrical or parallel. You can see. Okay, these are our IC1, IC2, IC3, etc. So you can note here at a given quantity of X. One second. So at a given quantity of X, given x, different axes have same slope. All right. So we can take an example like let u equals ln x plus y. Our MRS would be 1 upon x upon y, 1 upon x upon 1. Mux, that is derivative of ln x with respect to x, 1 upon x upon muy, that is derivative of u with respect to y, that is 1, equals to 1 by x. Okay. Now, no matter how much higher you go in terms of ICs, but the MRS would remain constant, that is 1 by x, and x star is itself constant. Now, another trick about quasi-linear is that to identify if a good is non-linear or linear, if in the MRS you get a single commodity x as the residual after calculating, like in this case we got only x in the MRS, then this commodity is a non-linear commodity. This commodity non-linear. Okay, all right. So this was all about Quasilinear utility. Now the optimal condition I have said it once, but let's write it. Optimality condition, it's the same. The absolute value of MRS must be absolute equal to absolute value of the budget line slope given by P2. Okay, so that must be clear now. Okay, so this completes our Quasilinear utility function. Now, if you have any doubts, to post in the comment box. We'll try to answer. Now, let's move to another or the our last utility function for semester 3 course. Now, there will be many more sub utility functions as you move ahead, but these are the main and the core utility functions in our part 1, part 2, part 3, and part 4 videos. Okay, so this is our concave utility function. Okay, concave utility function. Okay, now there is point which we need to understand first before going to concave utility function, uh, and it is that extremes are preferred to averages. The concave utility function, extremes preferred to averages of the bundles. For example, there are two bundles. Let's say 3, 7 and 5, let's say 9. 5, 9. Now, ideally, no, these are wrong examples. I need to correct them first. Just a moment. The sum is 10. We need to take 2, 8. Now, while comparing extremes and averages condition, we need to look at the bundles, and the total number of commodities must be the same. Like here, it is 3 plus 7, 10, 2 plus 8, 10. Okay. Now, ideally, what the consumer is deciding about is that which bundle to choose. Okay, here we have more of x than this bundle, and here more of y than this bundle. Okay, so there's a bit of a dilemma for the consumer, but if the consumer has concave preferences, then he will choose extreme bundles. Like, he will not choose any averages of these bundles. Like, what will be the averages? 5, 2.5, 3 plus 2, 5, divided by 2, 2.5. 7 plus 8, 15, divided by 2, 7.5. He will not choose this bundle. Since he has concave preferences, he will choose any of the bundles between these bundles, as these are extremes. This has highest of y, and this also has highest of y. These are extreme bundles. He will be choosing any bundle out of these two, not this one, not this one. As extremes are preferred to averages. Okay. Now let's move to the concave function and the general form of it. So we have general form, which is u equals ax square plus by square. A and b uh, can be positive constants, as we are talking about economic goods as of now. So these need to be uh, positive constants. Okay. Now what is the MRS in this case? Let's try to find out the MRS. It is MUX upon MUY. Take up this, and we get them as 2AX upon 2BY, or negative of x by 4. So remember, in concave utility function, we get MRS of the form x by 5. In convex form, in convex utility function, we every time get MRS in the form y by x. But in concave, we get of the form x by 5. This is a point to remember. Okay. Now let's see what is the optimality condition and how are the ICs made in this case. How are the ICs made in this case? Okay. Let's draw ICs. Let me copy this up. Let me copy this up. Okay. Now let's make our ICs. So you must have also some hint about it, that this is basically the circles diagram only in the first quadrant, as we have the form ax square plus by square. And this we get as this. Drawing can be a bit bad, but you can understand. Now we are drawing three diagrams for discussing three cases in optimality. We have good y here, good x here, y here, good x here, good y here, and good x here. Okay. Now remember max utility function, what we did there? A similar kind of a thing we need to do here. Okay. Once we draw, first of all, we need to assume a utility level. For example, let's take utility equals to 10. Okay. Now, whatever the function is given, we need to draw the IC with the intercept, x intercept, y intercept, and then draw a line joining the endpoints of the IC. Like we draw, we join these ICs. Okay. We join the endpoints. This can be the endpoints. Okay. Now let the price ratio, let the budget line be flatter than our red line. Okay. Now basically we have of the form a by b similar to the max utility function p1 by p2. Let it be greater than a by b, and p1 by p2, let that be equal to a by b. Okay. Now let's draw the budget lines corresponding to our conditions. Now here in this case our budget line is flatter. Budget line is flatter. Here our budget line is steeper than the red line. And here our budget line is coinciding with the red line. Budget line is coinciding with the red. Okay. Now the highest IC in this case is this point. You can understand it on your own now for concave. In this case it is this, and in this case either this or this. These are two octal bundles. Either the consumer will get only y or only x. E1, E2. Here only one exists. Here only one equilibrium bundle exists. Okay. So this was all about our utility functions. Here we have covered all our main utility functions, which comprise of Cobb-Douglas, perfect substitutes, perfect complements, max utility function, Allen substitutes, concave utility functions, and Quasilinear utility also. Okay, so today's class was just about these. Now the rest of the topics, like for example, we have food stamp program, and we have composite good case, then we have taxes and rations. Those uh, those topics we will be covering in our next parts. If you haven't watched the prior parts, do watch them as they are useful. For notes, you can check out the description. And towards the end of the October-November period, we will be uh, posting our full notes for macro, and MME. And due to time constraints, you can only cover some selected topics for macro, and MME. So that was all about it. Now let's meet in the next class.